Hello. In today's distributed networks lecture, we are going to be looking at network security and monitoring. In this series of lectures, this would be the last one for the semester, and there will be another course as part of your program next year where we will be talking about network security in more detail. So today it is mainly sort of some brief concepts that we'll be looking at, and mainly concerning to the things that we have covered so far in this module and some of the previous modules. So we will briefly look at land security, some of the security concerns and how we can mitigate those concerns in local area network environments. So that is the one thing that we'll look at. And we will also look at SNMP, or way of monitoring networks. So one of the things that we have focused on in this particular module is about building much larger network, expanding our networks into much larger network environments. When we have such larger network deployments, particularly small to medium sized deployments, some of the monitoring approaches that we can consider there, we will look at those as well. And also we'll briefly touch upon Cisco switch port analyzer, or SPAN, which is again another tool that we can use again to troubleshoot when we have network related problems in fairly large deployments. So let's start with land security. So when we talk about land security, here we are talking about security problems or security concerns from layers upwards of layer 3 up to layer 7 in the typical OSI model. Layer 2 is also something of concern. So because most of the general security solutions that you would come across, things like routers, intrusion prevention systems, VPN devices, they are mainly about protecting network environments, particularly when we are talking about much in the OSI model particularly, these other ones will be mainly concerning these layers. But when we think about it, it is also commonplace to find various attacks at layer 2 as well. So if we think about sort of the common layer 2 attacks, you may remember CDP from one of the previous modules, the discovery protocols that we have discussed previously. So one of the attacks is known as CDP reconnaissance attack. Things like telnet attacks, MAC address table flooding, VLAN attacks, DHCP attacks. We might have briefly touched upon these things when we were talking about each of these topics. Today we will sort of focus on those particular security attacks on those different levels. So if we think about the Cisco discovery protocol in particular and the type of security attacks that can happen because of that, this is mainly because CDP is a way for discovering other devices. CDP is there, or the Cisco discovery protocol is there as a layer 2 link discovery protocol. So it is a way for different devices to learn about each other. And when CDP is automatically enabled on a device, An attacker can listen to those information, they can request those information, or they can listen to the information that is being sent out from CDP, from the CDP protocol, and then they may be able to get a lot of information. So they may get information about the particular device, the software model on the device, or various things can be available through CDP, and just those informations may be enough for someone to target a particular attack on a particular network environment. So that is where we will think about mitigating these attacks, potential attacks through CDP. And one of the easiest ways to do that is disabling CDP on a device. So we can either do this in a global level, that is, we disable CDP altogether on that device. Say, for example, on a switch, we disable CDP altogether using the no CDP run command. Or if we want to let CDP enabled on certain interfaces that we know will not be compromised, and then we can disable it on other interfaces using no CDP enable command on those particular interfaces. So the nature of the CDP reconnaissance attack is this. So the CDP protocol is going to put out information as part of these packets that it is going to send out. And that information can be useful for someone if they want to launch an attack, if they may use that information to further the understanding of the network, and that could be sort of very undesirable in many situations. So we would disable that. So it's one of the simplest things we can do in an environment. One of the other sort of common issues that you may come across when talking about LAN security is telnet, and the fact that telnet is not a secure protocol. So rather, telnet is not a secure way of connecting to devices. But if a device is enabled with telnet, if telnet is enabled on a device, there are a couple of things that can be done. An attacker can launch a brute force password attack. So they can brute force attack. So that is trying out all the possible passwords, maybe starting from the commonly used passwords and then trying out a dictionary attack. They can try to get into the device, because telnet doesn't limit the number of access and that sort of thing. And the other possible attack is known as the telnet DOS attack. Again, here the attacker will continuously send telnet requests for telnet connections, so that telnet service become unavailable for people who want to use that. So again, these are two potential attacks when we are using telnet in our devices. And this is one of the reasons we would try to not use telnet in our networking devices and try to use SSH. So at this day and age, there's no reason why we would use telnet. We can always go for SSH unless there's a particular reason, but otherwise SSH is the way to go. And also using good passwords, changing them frequently, all these approaches are there. And also using access control list, and properly configured access control list, which we have covered in the previous lesson. So enabling access to SSH to these services only from certain hosts, and all those things we can do from access control list. And lastly, we can also do things like AAA. We will talk about authentication accounting authentication, authorization, and accounting. These are sort of network-based authentication mechanisms and things like that. We will talk about this in the next course that you will have next year. Then another type of attack, again, we have touched upon briefly previously, is the MAC address table flooding attack. So that is, if there is a malicious host and if they keep on sending malicious updates to a switch, the switch will keep on updating its MAC address table. So the malicious attacker can send fake MAC address sources so as to pretend like that they are another device. So if we keep on doing this, if they keep on flooding with these MAC address updates, so then the MAC address table can become full. So that is one problem. So the switch's MAC address table can become full, and the switch will be overwhelmed. And also, it can allow attacker to pretend to be someone else so that they can be receiving the frames that are supposed to be received by someone else. So again, a couple of issues that we can anticipate. And one of the simplest way to mitigate this is using port security. So that is, we can once a device is attached to a port, then we lock that in the trusted devices, and that cannot be changed. And also the ports that are not normally used will be disabled, so anyone cannot just come and plug in their device and start using it. So and there are a number of approaches like that we can take to avoid MAC address table flooding attacks. So the basic idea of implementing port security is mainly to mitigate MAC address flooding attacks. So with port security, we can statically assign a device. So a device will be attached statically. So we know that is the only MAC address allowed on a particular port. Or what we can do is another approach where we can take is we can let the switch to learn dynamically. So if a new device is attaching, for the first time we can let it connect, but after it is attached, then no new devices can be attached to the same port. So for example, if an attacker is trying to connect again, they will not be allowed. So we can have such a limitation so that any sort of attacker who may be trying to connect at a different point in time will not be able to connect there. And also we can use the same approach there. That is, say, for example, if one of the MAC addresses are already being used, again, it can not attach to another port once it is attached. So it will have to be allowed by the administrator. So we can have some limitations like that by enabling port security. Then when we talk about VLANs and when we are using VLANs, and particularly we have talked about using VLANs a lot in this module, and many situations where we may implement VLANs. And in such situations, there are a number of ways we may be impacted by VLAN attacks, and one of the main ways is called switch spoofing attack. So with switch spoofing, what happens is we have a device, so any network device, and that network device will pretend to be a switch. So it may be a host or whatever, the device may be anything, but from a programming point of view, or rather a networking point of view, it will pretend like that it is a switch. So any other devices interacting with them will assume that it is a switch. And then it will use 801q, the trunking protocol, if you again recall what we have discussed with VLANs, to trunk to another switch. So it will connect to another switch using these trunking protocols. So then what can happen is all the VLAN specific traffic can also go through this particular device, even though that is not supposed to be, it's not a switch, and traffic doesn't have to go through that, but it may pretend to be a switch that can lead to other VLAN. So information may flow to that. Number of simple ways we can mitigate this type of an attack. Either we go and explicitly configuring links. So we don't do auto configuration, we do manual configuration. We do explicit configuration of access links. So we can disable auto trunking and manually enable the trunk link. So if we know that is a trunk, we will enable that as a trunk. But if another person tries to link up as a trunk, it will not be auto configured. It will not be allowed for auto trunking. And one of the important ones that we would do is disabling unused ports. So this is again very much useful in many different LAN attacks, or avoiding many different LAN attacks. That is disabling unused ports so that others cannot connect to those ports and do various things. And one of the other things that we can do is changing the default native VLAN, because again, the native VLAN is by default, it is known to everybody. So if we can change that, that can be something. And implementing port security can also be helpful here. Again, by disabling those ports, or those ports not being used for anything else. So to prevent VLAN attacks, so there are a few things that we can do. So we can disable DTP. We can disable DTP, and we can do manual trunking. So if you want to enable something as a trunk, we can do manual trunking. And by default, the native VLAN is normally VLAN 1. Again, we can change that to something else and disabling the ports. One of the other things that we can do is, if we take all the unused ports and assign them to another unused VLAN, so then that in itself will isolate them separately. So anyone who is coming to that will only be able to access all the unused ports. So again, that can also be another approach there. So then when it comes to DHCP, again with LANs, that is again another common thing that we would use. And with DHCP, again, there are some common attacks that can be happening. One is called the DHCP spoofing attack. So with DHCP spoofing, what happens here is attacker will pretend that they are a DHCP server. So they may pretend like that they are a DHCP server. So for example, a client may mistakenly go to this server for DHCP request, and that may issue some malicious information and things like that. So again, that can be a problem. So that is a fake DHCP server pretending to be the actual DHCP server. That is one issue. So the actual legitimate server may not be usable there. Another approach is, so the legitimate server may still be there, but the attacker may be sending a lot of DHCP requests and creating a DOS situation, a denial of service situation, that is called DHCP starvation attack. So with DHCP starvation, the attacker is launching a lot of requests, so the actual client's request is not served. So that is a way of DHCP starvation attack, a DOS attack. So we can use couple of approaches to mitigating DHCP attacks, that is configuring DHCP snooping and also by configuring port security. So with DHCP attacks, one of the ways that we can prevent is called DHCP snooping. So with DHCP snooping, when DHCP snooping is enabled on an interface, the switch or any switches will prevent any information or any packets containing DHCP information. Say for example, say if that is the DHCP server, so that will be allowed to send DHCP packets. So it can send because it is the DHCP server. Whereas, so the attacker's device, say for example, this attacker's device, it cannot send any DHCP packets because it should not, because it is a server. So even a user PC cannot send any DHCP messages. So only authorized clients or the DHCP servers will be able to send DHCP messages, and the others will be denied. So that is DHCP snooping mechanism. So when we enable DHCP snooping on a switch, on an interface, only those interfaces will be allowed to send and rather send out DHCP messages. So what it would identify is, it would identify some of the ports as trusted ports. So for example, a port that is connecting to the DHCP server will be a trusted port. Something between a switch and a router would be a trusted port. So because these are the interfaces that would be expected to receive DHCP packets, because we know that is those are pathways from the DHCP server. Whereas the other ports, this one or this one, they are not technically part of trusted ports. They are untrusted ports because they don't connect to a DHCP server. So this is based on the knowledge that we have about the DHCP server. We will do that. Then another thing that we would try to do when we are building more secure network environments is using server-based authentication, or rather server-based authentication, authorization, and accounting. So the normal local approach is, normally we have a router. The router itself would act as AAA, or the authentication, authorization, accounting point. So the user will request from the router, and router will accept or deny that request. Whereas on a server-based AAA, the main difference here is the router would be sitting there in the middle, but the actual request from the user will come to the router. It will be passed on to the AAA server, which will do the actual authentication and authorization. So there should be some communication between the router and the server, and then based on that, user will be authenticated. So there are a number of approaches to implementing server-based AAA. Things like terminal access control system, or TAC-ACS plus, or remote authentication dial-in user service or radius. Again, as I said, we will talk about these particular approaches in much more detail when we are studying network security in the next semester. And one of the other things that we can have in secure network environments is using what is called secure device access. So again, in addition to authenticating users, we are also able to authenticate devices. So we can define certain port-based access control, and with an additional authentication policy, what we can do is, say for example, a device may try to connect to a switch, for example. Then switch may talk to the authenticator to see authentication server to see if that particular device should be allowed on that port. If it is allowed or not, that will respond, and based on that, the decision would be made. So again, this is another further approach that we can have, again, when we are building much more complex network environments. So doesn't have to be complex, but when we need security, when we need control over who can and cannot connect to the network, these are some of the approaches that we can take to securing our networks. So overall, when we talk about security and securing LANs, there are it is not a single approach. It has to be a combination of multiple approaches. So we could start with the low-level port security methods, then having DHCP snooping type approaches, then dynamic ARP inspections. Again, we will talk about some of these things later on, but a multi-layered approach that can mitigate security threats at different levels. So we could start by using more secure protocols or secure variants of protocols, things like SSH, SCP, and SSL. Changing passwords using strong passwords, again, a very common approach. Either not using CDP or enabling CDP only on select protocols. Having a proper VLAN plan, VLAN management, using a dedicated VLAN management approach, using ACLs to eliminate unwanted access, using port security. So these are some of the various things that we can do to make sure the network is secure at various levels. So as I said, it is not a singular approach. It will have to be at various levels. We'll have to think about what are the different approaches that we can take to secure our network environment. So the next topic that we will discuss today is SNMP. And SNMP is basically what is known as Simple Network Management Protocol. So it is a way of monitoring and managing network nodes. So what we would have here is, say in our network, we have a number of devices. So SNMP is a way of monitoring and managing all these devices from a central point. So what the alternative would be, we go into each of these devices independently, we look at them, we monitor them, we manage them independently. But with SNMP, what we can have is all these devices can be talking to one centralized server, and that centralized server is what we would identify as the SNMP manager. So the SNMP manager is the one that will collect all the information from SNMP agents. So these are the end devices that we are going to manage, and all the updates will be received, and also any configurations can be sent. So by using get, we can get updates from these devices, and using set, we can update configurations on those devices. Then in addition to this, we will also have what is called a management information base, or MIB. So the idea behind a management information base, or MIB, is that it is where all these collected information can be stored, and then that can be used for further analysis. Say we can collect and store all the data, and then it can be used for further statistical analysis and things like that. So the idea here is all the information will be generated from the agent. It will be received by the SNMP manager, and then that will be stored on the MIB for further analysis. So the SNMP agent, the device that is going to reside inside a managed device. So it can be a switch, it can be a router, it can even be a server. So any of these devices can implement or can have an SNMP agent, and then they can talk to the SNMP manager. So what will happen in a particular, in a typical device? Say for example, if we take a router, for example, this router will do various things will be happening in the router, and then all the information relevant monitoring and all these information will be stored on the MIB on the router. Then the SNMP manager can access that MIB using the SNMP agent, and they can either get the SNMP, rather get the MIB information, or they can set an MIB variable. So in a way, updating the configuration on a device. Then one of the other things that we can have is, what can happen is, say, we can periodically receive these updates. So one approach is when we need something, we can go and receive that information. But another approach could be we can periodically receive these updates. So that is the SNMP manager, the network management system can periodically poll the SNMP agents using the GET request. So it can send a GET request and ask for an update. And whenever there are new information or new relevant information, it can send back that. But one of the other approaches that can be done is what is called SNMP traps. So SNMP traps are there so that SNMP agents themselves can send some updates if that is relevant. So SNMP trap is, these are not requested updates, but these are updates that is relevant to the manager. Say for example, if there is a improper user authentication, for example, if somebody else is trying to log into this device using incorrect login details, so then that may be something that we want to know immediately. So then it can send a trap update saying unauthorized or unsuccessful login attempt. Or for example, another thing that can be something like a link status, say a connected link is failed. So again, an update can be sent saying this particular link is failed. So again, because it is, again, we would an immediate update would be more relevant there in that case. So the agent itself can send unsolicited updates. So those are known as SNMP agent traps. So normally we will do the get request and set request and responses like that, but traps are updates from the agents to the manager. So when it comes to SNMP, there are a number of different variations or other versions. Earlier versions didn't have any sort of authentications, but later versions used authentications. Or rather, the earlier versions didn't have much more strong authentications, but later on much better authentications. Particularly, SNMP v3 has options even for using data encryption and so on. So again, there are some variations, and depending on the network environment, network requirements, we may use one or the other. In the earlier versions of SNMP, they used what is called a community string. So a community string is basically a string, and if that string is known, people can access the MIB. So the only limitation is as long as you know the community string, then you are able to access the MIB or even update the MIB. So it's not a very secure way of doing things, but a fairly simpler way of doing things. Then when we think about the management information base or the management information base object ID, it is a way of organizing the various information that is available in a particular device. So most devices will implement sort of the standard common public variables, and in addition to this, some of the vendors may also implement their own additional variables. So there are sort of standard set of variables that can be implemented or that can be available there in the MIB. Then in addition to that, there could be other proprietary or vendor specific variables there as well. One of the interesting parts about SNMP version 3 is that we can use encrypted channels. We can use message integrity and authentication. We can have encryption and we can have access control. When compared to the approach of using community strings, this is a much secure, much better approach. So because when we can have authentication and integrity, message integrity, so we can make sure the information is received from the expected party. Say, for example, if we receive an update from here, we can authenticate and make sure it is actually from that particular managed node. By using encryption in between, again, anyone else trying to access will not be able to access. And using access control, again, nobody else can access MIB, only people who is allowed are allowed to access it. So when we think about setting up SNMP on a Cisco device, for example, in a Cisco router, it is fairly straightforward. If you want to configure it with a community string, we can use the command SNMP server community and the community string there, and we can specify whether it is a read only or a read write. We can then additionally give some optional parameters such as SNMP server location, server contact, and also various access control ACL based access control lists. So one of the security mechanisms we can implement even when we are using community strings is by using an access control list. So even if we cannot control it using a more secure like encrypted approach and all, we can still configure ACLs as a restriction mechanism. So with SNMP, there are number of security vulnerabilities are there, particularly with version 1 and 2. The issues of community strings, the best approach would be to frequently changing community strings. And it is always, so if we are using community strings, they are changed frequently and also they must be strong. We can use ACLs, so to limit which devices, who can access and all that. So again, ACL can help with that. Or we can go with SNMP v3 because it provides much higher security authentication and encryption, which would be a much more suitable approach there. So that is what would be suggested as a best approach. So if you want to configure SNMP v3, again the approach is we will set up an ACL. So we will configure a standard ACL that will permit access only to the SNMP managers. So we will only permit the SNMP managers there, and we will configure the SNMP view again to identify which OIDs the SNMP manager will be able to read. Again, we can specify that which information can be made available there, and then we can configure an SNMP group and specify which ACL is allowed to access. So we will specify the ACL there, and we can configure the usernames, associates with groups, and all these things. Additional things can be configured, particularly encryption and things like that also. So that is basically configuring SNMP v3. So as I said, like configuration details are pretty straightforward as long as you know the commands. The idea is the same. So as an example here, what we can do is we can go and create an ACL saying permit admin, and then there we can specify what is the admin network there that we will permit. So then that is configuring the ACL there. Then after we have configured the ACL, we can go to the SNMP view read only there, and we will include ISO there. Only ISO is included. The ISO level is included there. And then we can go and assign the admin and v3. And also we can assign the access ACL list permit admin there to the SNMP RO. So then after that, we can go and configure the user. We can configure authentication, or rather encryption, and so on. So that is a simpler way of, it's a fairly straightforward way of configuring SNMP v3. The last topic that we will briefly touch upon is known as switched port analyzer or port monitoring, or SPAN. The general topic is port monitoring. Switch port analyzer is a protocol for doing that. So the idea of port mirroring or port monitoring is this. So usually, say in our network, the communication is between these two devices. So then we can additionally in our switch set up another device, a third device that will receive a copy of all the traffic going through there, and we can monitor that. So it is a way of doing packet analyzing type of an activity. So what we do is by connecting as a port mirroring device, we will receive the duplicated traffic that is happening through the switch, and then we can monitor that traffic. So again, this can be useful as a monitoring tool. So we may do this for a number of reasons. Uh, uh, we can collect, say, for example, network traffic and analyze the traffic to see if there are any sort of suspicious traffic. We can use this for a couple of things. We may use them with packet analyzers or packet analyzers, things like Wireshark and things like that, where we can capture and monitor what is happening in our network environment, or we can use them with intrusion prevention systems. So again, these are servers that will monitor the network traffic, and they will see if there are any abnormality, unexpected traffic patterns, and see if there is anything suspicious in the network environment. So this type of port analyzer or span can be implemented as a local or remote span. So when we talk about a local span, that is basically if these two are the devices or the traffic that we want to monitor is between these two devices, the monitoring device is also connected to the same switch. So when we want to use local span, the traffic that we are monitoring is on the same switch as that we are connected to. So the we are in the same network. So that is the local network. When we talk about remote span, what we can have is, so again, we are monitoring the traffic between these two devices, but the sniffer device or that is connected to a different switch. So then what we should have is we should implement a VLAN, and through that VLAN it should be trunking through that switch to the device. So then in a way we may appear as we are directly connected, and we can do the sniffing there. So configuring span is fairly straightforward. The idea is we just need to go there and give the monitor session and give the source and destination. So we go and specify what is the source for the monitoring and what is the destination for the monitoring. So here source is attached to F01, and the destination is 02. We can also use span as a tool for troubleshooting our networks. Say, for example, if we can use span, so say in our monitoring point, we could receive all the information and see why, say, for example, the network is slower in the network environment. Are there any sort of issues in the network? Any part of the network is not functioning? Are there any particular type of traffic that is unexpectedly happening more? So there are many reasons why we may use span. but it is a way of monitoring, and then by monitoring we can gain a lot of understanding, and then we can act upon that. So when we think about building larger network environments, one of the important aspects that we'll have to consider is think about security. So when we think about security, in today's lesson, we sort of briefly touch upon some common LAN security attacks and some ways of mitigating them, and also some approaches for monitoring and managing these network devices. As I said, we will talk about more in-depth network security topics later in the next semester. And today's lesson would be the last of this module. So if you have any questions, any concerns on the lesson so far, please feel free to post them on LMS, or please reach out to me and we can have a discussion on these things next week or any other time that is preferable. So until next time, thank you for joining. Bye.